Good afternoon, everyone. My name is Sifra, and I'm a Google Cloud architect here at Clair Services LLC. Today, we're going to talk about Google Cloud VMware Engine, and we're going to focus on networking. Here's what we're going to cover in this presentation. Our topics for this presentation are IP planning, understanding VMware Engine network and peering, high level network architecture, common traffic flows, and workload migration using VMware HCX. Now, moving on to the IP planning required for deploying Google Cloud VMware Engine, there are four board types of side ranges which are required within Google Cloud VMware Engine. The first one is the management block side range, which is used for deploying the management components of the private cloud like vCenter, NSX, and HCX. The cider range also dictates things like the maximum node count of the private cloud, number of HCX appliances, and maximum number of NSX edge VMs. The cider range cannot be changed later after the deployment, so it is very important to plan this properly, taking into account the current and future needs of the private cloud. The other important piece to highlight here is that today, all the private clouds are deployed using IP Plan version 2 as default. IP Plan version 2 includes the HCX subnets within the management CIDR block. You can see the maximum number of nodes possible with the management CIDR range in the table. Some of the other subnets which may be required are um, the edge services, which is used for internet connectivity. The second is the workload subnet. This will be the network where your workload VMs will reside. The number and size of this subnet will vary as for each customer environment. And last of the service subnets, these networks can bypass uh, the overlay networking within Google Cloud VMware Engine and thus can be used for workloads like backup replication appliances, disaster recovery appliances, providing high scale linear throughput and packet processing for even the largest scale private cloud. So uh, consider it as your um, main source or your back end connectivity. So it needs to be strong. Now, let us understand more about VMware Engine networks. Every private cloud is connected to a VMware Engine network. It is a global VMware network that provides connectivity to private clouds and enables the communication between a private cloud and a VPC, between different private clouds, or connectivity to on premises. The name of this VMware Engine network is the standard VMware Engine network. An important point to note here is that any project which was created before November 2023 used the legacy VMware Engine network, which is regional, not global, and it required private services access to peer your VPC network to the VMware Engine network. Now we can either create a new VMware Engine network and attach it to the private cloud during the process of private cloud creation, or as you see in this slide, you can also create the VMware Engine network separately under the VMware Engine network tab. And then when we are creating the private cloud, we could attach this VMware Engine network to that private cloud. To establish connectivity for the private cloud, we will have to configure peering for the VMware Engine network. These are the different peering types available. Standard is used for peering a VMware Engine network to a VPC. VMware Engine Network is for peering to another VMware Engine network. This enables private cloud to private cloud communication. Private service access is used to establish private connectivity to services which are using private service access like Cloud SQL, File Store. NetApp Cloud Volumes and Dell PowerScale are used for external storage options for VM workloads running on Google Cloud VMware Engine. These storage options are covered in the storage presentation that we did earlier. Please look at it if you would like to learn more about storage in uh, Google Cloud VMware Engine. Finally, you can use third party services for consuming other third party services and for any uh, other future integrations that you may have. Let us look quickly at the high level networking architecture here that we're talking about. Starting from left to right, you have the on-premises data center which can establish private connectivity to Google Cloud using Google Cloud Interconnect or Cloud VPN or any other supported IPsec VPN. Both the interconnects and VPNs terminate in a consumer VPC. This VPC could be a standard VPC or shared VPC, multiple different architecture like hub and spoke and various others are supported here. The consumer VPC where the integrated VPN is terminated is paired with the VMware Engine network using standard VPC peering. A single VMware Engine network can pair with multiple other VPCs to enable different communication patterns. And finally, a private cloud is attached to a VMware Engine network. Within the VMware Engine, private cloud networking and security services are provided by VMware NSX. On the right-hand side of this slide, you can see an example topology within VMware and private cloud. However, these topologies will vary based on your customer's requirement. For internet access, there is a service called Internet Gateway Service. This can be used to access the internet directly via the Google Cloud VMware Engine service. Similarly, there's a public IP service, which is also available that can be used to expose VM workloads over public networks. The DNS here configuration is also simplified and it's covered in more detail in a separate presentation that we will do. With this, let us look at some of the basic traffic flows. This slide shows outbound internet connectivity. We have three different options. The red line depicts outbound traffic via the Google Cloud VMware Engine Internet Gateway service. The orange line depicts outbound traffic via the consumer VPC to a third party appliance behind an internal load balancer. And the last blue option is to take all the traffic back to the on premise environment. This is achieved by injecting a default route into VMware Engine network. Please keep in mind that this option will introduce additional latency for workloads since all the traffic now would be going to on-premise before going to the internet. Similarly, just like the outbound options, there are three options for inbound internet traffic. The red line depicts exposing VM workloads on Google Cloud VMware Engine using the public IP service. The orange line depicts traffic inbound through the consumer VPC using Google Cloud external load balancers or other third-party appliances. And finally, the blue line depicts traffic coming via the on-premises environment. Let's take a look at the Google Cloud native load balancing options for workloads, which are residing on Google Cloud VMware Engine. We can now use our regional external load balancers directly for workloads on Google Cloud VMware Engine. Now, apart from the scalability and reach which our load balancers provide, we can also protect the workloads using services like Cloud Armor once we start using our external load balancers. Similarly, our internal load balancers also support Google Cloud VMware Engine. Now we can also use our global external load balancer by doing load balancer chaining. Within the private cloud, VMware NSX also provides various load balancing options. Finally, let us talk about migrating workloads to Google Cloud VMware Engine using one of the inbuilt tools called VMware HCX. The VMware HCX license is included as part of the Google Cloud VMware Engine. VMware HCX facilitates seamless migration and workload mobility between an on premises environment and Google Cloud VMware Engine. It enables bulk migration of virtual machines, vMotion based live migration with zero downtime and network extension for layer to network connectivity between sites. HCX migrations are initiated from the source side, and on the source side, having NSX is not a mandatory requirement. HCX works with both standard vSwitches and distributed vSwitches. This slide depicts a high-level architecture of using HCX for migration. HCX establishes a secure tunnel between the on-premise environment and Google Cloud VMware Engine. For network extension, we recommend to use a high availability setup for network extension appliances. Other important consideration are on opening the required firewall ports, setting the correct MTU, and understanding of traffic tromboning must be taken into consideration during design and deployment. And with this, we've reached the end of the presentation. Thank you so much for watching.